Okay, here we go, part B. So find to the nearest minute, okay, so when you change that to hours, minutes later, the maximum length of time that the telephone can be left unattended. So that the probability of missing a telephone call is less than 0.1. So this is a bit funny because this is talking about missing a telephone call, so it's actually a reverse statement. So the probability of leaving a call unattended is x equals 0, meaning no calls. But to miss a call as well would be the opposite, would be 1 minus this terminology. So 1 minus not picking up the call. So this is going to be a higher probability. And all of this must be less than 0.2. So this would be our statement. We also need a new distribution as well because we're working at time. Let's let the new time variable be t, yeah? Because we want to find out exactly how many hours per t. So t per hours or t per minutes. So it'll be x is a Poisson distribution with mean 2.5 t per hour. So once we work out the t value, we can work out the number of minutes that can be missed. So let's have a go. Okay, hopefully you guys are following me with this one. So let's rewrite the statement, yeah? So what do we have? Yeah, so you could actually, let's just throw this on the other side, yeah? Well, let's keep it as this. So we got 1 minus the probability x equals 0. So using a Poisson distribution, it'll be e to the minus lambda. So e to the minus 2.5 t times lambda, which is 2.5 t to the power 0 over 0 factorial. Okay, and all of this should be 1. So I don't know why that's even there. And all of this would be less than 0.2. Now this is just a case of solving. So we need to make t the subject. So what we could do is plus this to the other side and subtract 0.2. The other side, so we have 1 minus 0.2 is 0.8, less than e to the negative 2.5 t. Taking the natural log on both sides, so we got ln 0.8 is less than ln of this, and that will drop, so be minus 2.5 t. And now inverting the position, so throwing 2.5 t to the other side, so it'll be a positive 2.5 t, because sometimes working inequalities can be messy. And throwing this to the natural log to the right side, it'll be minus ln 0.8. And that's it. Now all you do is simply divide 2.5 across. So you're going to have t is less than minus ln 0.8 over 2.5. Put this in a calculator and you should get 0.0892 ... 57 ... hours, and to convert this to minutes, well, just times your result by 60 and you should get the time to be less than 5.355 minutes. 55 minutes.